Hi, welcome back. So in between video 1 and video 2, you needed to create your own driving question board and ideas for investigation. As we go over the storyline for the unit, keep those questions in mind. And at the end of this video, I'm going to have you review your questions that you came up with based off the anchoring phenomena and try to identify what lessons answered those questions. Or did your ideas for investigations get included at some point in the unit? So this is kind of, this video is kind of looking at the big picture. So I'm going to show you the unit storyline document. And this is, there's a lot going on here. So I'll kind of break it down quickly to show you how to read this document. For each lesson, there's a kind of a question that somehow relates to the big question for the unit, which is how can containers keep stuff from warming up or cooling down? And then each lesson has a kind of sub question to that that students investigate. So at the end of this video, look and see if any of your questions that you came up with on your driving question board are included in the unit. The second part, the second kind of thing to look at is the different routines for OpenSciEd are kind of called out here. So we did the anchoring phenomena routine. There's the investigation routine. We'll focus on like the putting pieces together in a little bit, that routine and what's involved in that. There's the problematizing routine, more investigations, putting pieces together. So you can kind of see what the routine, the focus routine is going to be in each lesson. And then there's a summary of what students are supposed to figure out in that lesson, basically answering that question for that lesson. And then there's some sort of visual representation. You can see that the students are going to be revising their models quite often in this unit as they answer different questions. And then down here in the green in between each lesson are the navigation routine, like how to prompt students to kind of take stock of what they've learned in this past lesson and think about what questions come up based off their past experience and try to make that bridge between what we learned in lesson 1 and what we learned in lesson 2. So the navigation says, we figured out that the fancy cup does keep a drink colder for longer than the regular cup, but we're curious about which parts are important. And so in lesson 2, they look at different features to test to see which aspect of the cup is important. Is it the lid? Is it the double walls? Is it the color of the cup? And then they want to see, well, does that help for keeping a drink hot as well as cold? And so then they compare things with the hot versus the cold. And so you can see how like there's like a natural kind of sequence there. And so you want to kind of look at this green to see how each lesson kind of connects so that it's more coherent for the student to understand. So on the unit landing page on the OpenSciEd website, they give an overall summary. So that's where you find the storyline there. That's an important document. There's some sample lessons and stuff. Here's where the performance expectations are listed. So a lot of physical science and engineering performance expectations in this unit. So structure and properties of matter, energy, a lot, engineering and design. And then there's the SEPs and the cross-cutting concepts that are kind of focused on in this unit. So that might be important to kind of see where this fits in your scope and sequence with the curriculum you've been using. Here's the OpenSciEd scope and sequence document. And so there's a list of performance expectations and arrows to show how the lessons interconnect. There's definitely connections between the light and matter unit and the thermal energy unit. Those especially kind of are important in one of the lessons where you start to talk about what effect does light and sunlight have on heating things up. The students are going to draw on a lot of their knowledge from the light and matter unit that they did first. And this thermal energy unit will have applications, for understanding weather and climate and phase change and convection currents and conduction, convection. Those are all going to be covered in the next unit. So that's kind of the overall sequence for OpenSciEd. So one of the focuses of this video is going to be about the putting pieces together routine. So I'm going to, and we saw like in the storyline document that if we go back to that routine appears in lesson 6, lesson 14, and lesson 18. That also happens to be when a lot of the major assessments are as well. So I'm going to open up the teacher handbook, which goes into each of the routines in more in depth. And this handbook sort of applies to all the units and gives more specifics into each of the different routines. So I want to focus this video about the putting pieces together routine and what the main elements are. So the first element is kind of taking stock and thinking about what the students have learned. So as you see in like the storyline, there might be like a series of 4 or 5 investigations that students do. And then at a certain point, you need to kind of synthesize that information to make sense of your phenomena. So there's a lot of prompts to try to get students to like figure out what evidence they collected, how it relates to the big question of the unit, and to summarize their learning for each lesson in their progress trackers or model trackers. You'll see prompts for those within the curriculum of when to update your model tracker. Throughout some of the units, you might be creating posters for scientific principles like conservation of matter, or have a word wall that you've been developed. So it's important to kind of highlight those when you're taking stock to try to pull in all these different resources you've found through these different investigations. So basically, it's like when you're making a jigsaw puzzle, you want to make sure you have all the pieces on the table before you start putting them together. And so there's a couple different ways in the second element of the putting the pieces together, where students might create like a gotta have it checklist, like what are the important parts of the model or of a complete explanation, and you generate that together as a class to make sure that like you're including all the important pieces of evidence. you might try to revisit your initial consensus model and try to create a new consensus model and do some drawing in small groups or in partners or as a class to try to get everybody's ideas on the table now that you have a collection of evidence. So yeah, one of the products that might come out of this routine is a new consensus model. And I'll show you an example of a revised class consensus model from a different unit. Another element might be revisiting the driving question board, and maybe at a certain point, like, oh, well, we've addressed these questions, but we've left these unanswered. And so then that can help you navigate the students to say, oh, well, we figured out what happens with the condensation on the outside of the cup, but we don't know what role like light or is happening, or like we know matter isn't going back and forth, but how is heat moving? So those are maybe some things that didn't get addressed in the driving question board, and so that gives you motivates the next part of the lesson. And then another element might be, well, we figured everything out, but let's try to apply what we learned to another phenomena. And this gets kind of relates back to your related phenomena discussion. So now that we've understood like the cold cup and how it works, how would it relate to icing an injury or designing a blanket to keep me warm if I'm out camping and don't have electricity to keep me warm. So that's another part of that routine, is trying to apply it to a related phenomena. Okay, so those are kind of the main elements of the putting pieces together routine. And again, those are come up in lessons 6, 14, and 18. Here's an example of from another 6th grade lesson that where we revised our models. And I did this remotely using that Padlet app. And so students revised their initial model that they had done on Padlet, and I had them write comments on each other's and ask each other questions as a way to kind of share ideas and think about, you know, what do we need to include, what evidence do we have to add to our initial models. Let's see. Another example from that unit is we built on our initial consensus model by looking at it from different perspectives, like looking at it at the Earth's cross section later in the unit. So we added that detail, and then we added some data to it. And here we're putting kind of together a checklist of what we need to add to our model. So this is an example of us doing that, putting the pieces together routine to make a more complex model of our system. So you can see how this has quite a bit more detail than what we initially kind of came up with. So as the lessons progress, in lessons 6, 14, and 18, you're going to be putting the pieces together and making sense of all these investigations and how the pieces fit together. And then you can see in lesson, or in video 4, I'll talk about the main assessments for this lesson, and that those line up to with that putting the pieces together routine. So that's pretty much it for this video. So you can take some time to explore the unit storyline and what questions are asked, and see if the unit storyline addresses the questions you came up with. So I showed in video 1, I showed this driving question board, and then these has some student questions on it. So hopefully you added some of your own questions, and maybe add in, let's put a text box. Like I see talking about, what direction the lesson about light that's covered in like lesson. I could look at the storyline and see what lesson covers the stuff about light. So let's look at the storyline. So just as an example, let's go back to the storyline document. Okay, so it looks like they're going to cover information about light in lesson 7. So I'd say, oh, well, that question that the students came up with in the initial consensus model, that appeared in lesson 7. So this is kind of a useful exercise to see like when the questions are going to get addressed in this unit. So you can kind of see like the flow and help students kind of navigate, from one lesson to the next based off their own curiosity. So that's kind of the activity I'd like you to do for between the first video and the second, between the second video and the third video. Look through the questions that you came up with and see where they appear in the storyline. I think that activity will help you kind of get a sense of what gets covered in this unit. All right, that's the end of this video. In video 3, we're going to talk more about norms and student discourse and how to get students talking about science.